Hello everyone, I'm Siddharthan. Currently, we are in the eighth module of our hands-on machine learning course, and in this eighth module, we are discussing about the topics such as cross-validation, model selection, hyperparameter tuning, and model evaluation. In the last video, I explained you what is meant by precision, recall, and F1 score, and we have also seen what are all the formulas involved in this and how we can calculate this precision, recall, and F1 score. And in this video, we are going to get an hands-on experience of these three concepts. Okay, so I'll show you how you can calculate this metrics in Python for a machine learning use case. So that will be the agenda for today's video, and let's get started. So for this, we will be working on the art disease prediction dataset. So in my YouTube channel, I have already posted video on predicting whether a person has art disease or not based on this dataset that we have worked on. You can see here. So 1 year represents so people with art disease, and 0 represents people who doesn't have any art disease. So this is what we have worked on. So if you want a detailed explanation on all the data processing parts and how we are training the model and all those things, so I'll give the link of that particular video in this video description. You can check that out. Okay, so here I have uploaded this art.csv, which is my dataset file. I'll also give the link for this dataset file. So in the last video, so like before this precision, recall, and F1 score video, I have explained you in detail about this accuracy score, and how we can find this accuracy score for training data and test data and so on. So this is the accuracy score we have, which is 0.85, which basically means 85 percentage. So 85 percentage means, so out of 100 predictions, your model can predict 85 correct data points. So that's what accuracy means. And we have also discussed that there are some limitations to this accuracy score, because it doesn't tell us the rate of true positive, true negative, false positive, and false negative, and so on. So that is why we are focusing on the metrics such as precision, recall, and F1 score. So where we have understood the other advantages that we can get from using these metrics. So if you haven't watched the previous video, I suggest please watch those things. So in that case only you can understand this clearly. So this is the definition for this precision. So it is basically the ratio of true positive to the total number of predicted positive. Okay, so true positive means, so in our data set there are people with art disease and without art disease, right? So true positive basically tells you how many people are predicted as people with art disease, and they actually have art disease. Okay, so here the predictions made by the model matches with the actual positive. Okay, so false positive is just opposite to it. So in that case, a person doesn't have art disease, but our model is telling that that person may have art disease. So that is what we call as false positive. So this is how it corresponds to the true negatives and false negative and so on. So you would get a clear understanding of these terms if you watch the previous videos. Okay, so now we have this accuracy score details and so on, and now let's try to understand how we can calculate these three metrics: precision, recall, and F1 score. And other important thing is, this is used only in the case of binary classification problem. So binary classifications means we are classifying the data points into two classes. So in this case it is person with art disease and person without art disease. The other example is, you can try to predict image represents a dog or a cat. So there are only two classes, and we are trying to predict among these two classes to which a particular data point belongs to. So that is one thing. And so yeah, let's get started with the coding aspects. So first I'll import this precision score from sklearn. So from sklearn dot metrics, so this is where we have this accuracy score, mean absolute error, and so on. So all the evaluation metrics will be in this metrics module of sklearn. Okay, so from sklearn.metrics, let's import precision score. So precision score. So I'll run this one, and now we have to pass the true value and the values predicted by our model. So we have already did those things in this step. So if you don't understand this, as I have told you, please watch that accuracy score video and the art disease prediction video. You can get a clear understanding of it. So you can find the link in this video description. So here you can see, so we are training our model here. So we are taking a logistic regression model, and we are specifying the iterations, and we are training it with the training data X train and Y train, and we have split our data into training data and test data. So X train and Y train are my training data, X test and Y test are my test data. Okay, so you can see, so it is 80:20 ratio. So test size is equal to 0.2, which means test size is 20%. So we have split the data and we have trained our model using this training data. So this is the accuracy on the training data, and this is accuracy on test data. So here extreme prediction is the values predicted by your model for the training data, and X test prediction is the values predicted by your model for the test data. Okay, and the true values are your Y train and Y test. Okay, so this is the true values for training data. This is the true labels for your test data. So we have to pass these four things individually in order to calculate this precision score, recall, or reference score. So whatever we need. Okay, so here I'll make a comment as precision for training data. Okay, precision for training data predictions. So we will be finding this accuracy score as well as precision, recall, and difference score for both training data and test data, because then only we know whether our model is overfitted. Overfitting means in that case your model would have overlearned, and when that happens you will get a good accuracy score, good precision value only on the training data, but your model performs really bad in your test data. So that is what we call as overfitting. So the main idea is to make sure that the training data accuracy and test data accuracy are close to each other. In this case, the training data accuracy is 85.54% and the test data is 80.33%. So we know that it is almost close. So there is no overfitting is happening and the model is working well. In fitting aspects, overfitting and underfitting aspects, we don't have any issues. So now we have this precision for training data prediction. And here I'll create a variable as precision train. So this is the precision value for the training data. And here we have to use this function precision score. So precision score, and here we have to pass the no, we have to pass two parameters. One is the true labels and the other one is the values predicted by your model, which is your extreme prediction. So this is just sorry, so it's extreme prediction. Okay, so here this is just similar to the accuracy score that we are calculating. So it is like very similar to it. So this is the values predicted by your model. As you can see, model.predict x test. So we are passing the test data points, features, and we are predicting the labels, and we are storing this in x test prediction. So this is where we are predicting it. So this is for test data, and the same thing we have done for training data as well. So we just have to follow these steps. So I'm just giving this here as precision underscore train, precision score. So Y train and X train. So this is my true labels for my training data, and these are the labels predicted by my model. Okay, and here let's print training data precision. Okay, so training data precision is equal to precision train. Great. So here we are creating a variable, and here we are using this precision score, which will calculate this score using the true labels and the labels predicted by our model. Okay. So this will give us a value, and this value will range between 0 and 1. 1 being your all the values are actually correct. So that's what it means. So it ranges from 0 and 1. So if you want, you can convert this into percentage as we have done here. So you can round this to two decimal points, and you can include a percentage symbol and multiply with 100. So it basically converts this value, which ranges between 0 to 1, to a percentage value. Okay, so in this case the percentage is 82.9. Okay, so almost 83 percentage. So what this 83 percentage means is, you can refer to this definition. So it is the ratio of true positive to the total number of predicted positive. Okay, so I have explained this in my previous presentation. As you can see, precision is the ratio of the same definition. So it's basically true positive divided by total predicted positive. So out of all the predicted positive, how many are actually truly positive? So in our use case, it's out of all the people who are predicted as those having R disease. Let's say that 100 people are predicted as with heart disease. Out of those people, how many are actually having heart disease? So that is my true positive. So total predicted positive means all those people who are predicted to be having some heart disease. So that is what precision tells us. So the disadvantage with accuracy is it cannot tell us these details, and these details are very important for us. And I have also explained this in the previous video itself, that it measures the error caused by false positive. Okay, so total predicted positive is nothing but true positive plus false positive. So it will kind of help us to know the error caused by this false positive. So it will tell us this particular thing. So 82.9 percentage are true positive out of the total predicted positive. Now we can find the same for the test data as well. Okay, so I'll just copy this one. So this is for training data precision, and I'll just paste this code and I'll just change this training to test. Okay, so let's name this as precision test. And so here the white train should be replaced as white test, and x train prediction should be replaced as x test prediction. So this is my test data precision, the precision test. Okay, so I'll just check everything is correct. The precision for test data prediction, precision test, precision score, y test, x test prediction. Okay, so if you see here, x test prediction is nothing but the labels predicted by my model for my test data, and here y test is my true labels for test data which we have splitted using this train test split. So this y test and the values predicted by my model is stored in x test prediction. So similarly in this case, so we have used y train and x train prediction. Now we have to use y test and x test prediction. So I'll run this one. So this is my test data prediction, which is like 0.818. So almost it's 82 percentage, right? So this is the precision. So recall is, so the implementation is almost the same. So we just have to replace this precision with recall, and everything else kind of remains the same. And this is the definition for this recall. I hope you have watched the previous video. So it basically tells you the ratio of number of true positives to the total number of actual positive. Okay, so I'll just open this PPT quickly. So this is what it means. So true positive divided by total actual positive. Whereas in the case of precision, we have worked on total predicted positive. So if you don't understand what this total predicted positive means, or true positive, false positive, please refer the previous video. Okay. So let's go to this recall. So here we have to change this precision. So in sklearn.metrics itself, we have another score called as recall. So from sklearn.metrics, I'm importing this recall score, and I'll just copy all these things. I just have to change this precision score to recall score. Okay, so I'll copy this one as well and paste it here. Now let's copy this recall score, put it here. Okay, yeah, and yeah, so here as well, and I'll just change these things. So this should be my recall for training data prediction, and let's name this as a recall train. Recall score. So all these parameters kind of remains the same. So this will be my training data recall. Okay, so here we have to replace this. I'll just copy this recall and replace this precision. Okay, so this is the recall for test data prediction, and this is my test data recall. So precision test. So let's run this one. So this is from sklearn.metrics. We are importing recall score. So recall train. So recall of the training data is recall score of y train, which is my true labels, and x train predictions. Training data recall. Okay, so here we have to change this. Precision train should be replaced with recall train. So this will give you the recall value, which is 92.4 percentage, and for the test data we get the recall as 81.81 percentage. So for this particular data set, I think the for the test data recall precision and recall kind of remains the same. Whereas you can see the change in this precision and recall for training data values. Okay, again, so this is the same for the F1 score as well. So you just have to rename this. So I'll copy these three cells if possible. So I'll copy these cells and I'll paste it here. Okay, so now we can replace this recall score to F1 score. Okay, yeah, so this will be my F1 score. So again, F1 score is, it's kind of a wrapper of these two values. So it will try to find a mean of precision and recall, but it is not a normal mean but a harmonic mean, and this is the formula for it. So 2 into precision into recall divided by precision plus recall. So this is the harmonic mean. If the precision and recall value is the same, in that case you will get the same value as your F1 score. So just like mean. So this is what we call as an harmonic mean. So here we have this F1 score. So let's replace this. F1 score. So let me put this recall train as F1 score of train. and F1 score. Okay, so let's rename this recall test to F1 score test, and this should also be renamed to F1 score. So as we know that Y test X test prediction and Y train X train prediction kind of remains the same, as they are the parameters on which we are working on. So here let me put this as F1 score for test data prediction. So let's run this one. So here it is recall train, so it should be replaced with F1 score train. This should be replaced with, okay, so here it is correct. So here we are calculating the F1 score using this F1 score function, and we are storing it in this F1 score train. So white and index train prediction printing training data F1 score. So this is the same, so this should be training data F1 score, and in the next step we have test data F1 score. Let's run these two things. So here the training data F1 score is 87.4 percentage, and the test data F1 score is 81.8. It's almost 82 percentage. So as you can see, the precision for training data is 82.9 percentage, and the recall for training data is 92.4 percentage. So you will get this harmonic mean value to be 87.45 percentage, which we will get using this particular formula. Okay, as I've told you, in this case precision and recall kind of remains the same for test data, so the F1 score will also be the same, as it is just another form of a mean. Okay, so there is just one more thing that we can do here. So instead of calculating this precision recall and F1 score separately, we can also kind of build a function through which we can print all these values. So the reason we are calculating this different separately is we don't need all these three metrics all the time. So they are like there are like specific advantage to it. So say for example, in the case of precision, it is very helpful for us in order to in the cases where false positive rate is critical, or where we wanted to measure the error caused by false positive. Whereas in the case of recall, it measures the error caused by false negative. So whenever false negative predictions are critical, in that case we will look into recall more specifically. So that's why I just wanted to show you how you can calculate this values separately, so you will understand this with this particular example. If you have seen the previous video where I've explained you why is that critical, why false negative is critical sometimes, and why true negative, sorry, why false positive is critical sometimes. So you can understand from that video. Now let's just create a small function incorporating all these things: precision score, recall score, and F1 score, which will help us to give all these values when we run the cell for one single time. So I'll name this, I'll just put some text here as precision, recall, and F1 score. Okay, so just a second. So F1 score, and here we are going to create a function. Okay, so DEF, which stands for define, and let's name this as precision, recall, and F1 score. Okay, so this is the function that we are creating, and here we need two parameters. So the first parameter is true labels, and the next parameter is our prediction labels. So let's put this as spread labels. So true labels is the Y train or Y test. Okay, so what we have here, so while splitting it, yeah, so Y train and Y test. Okay, so in this case the prediction will be your X train prediction or your X test prediction. So that will be the two parameters that we have to give here. So here let's create three things. So one is precision value is equal to, and next let's create okay, so let me just complete this. So this will be precision score. So first you have to import this. Okay, so I have already imported this precision, recall, and F1 score separately. So if you are not doing this individually, you need to import these three functions. So precision score, so I have to say true labels comma red labels. Okay, and I'll just copy this, and we just have to replace this precision with a recall. So I'll replace this precision with a recall. Okay, so this should be my F1 score value. So here also we have to replace those functions. Recall score, and this would be my F1 score. Okay, so if you are wondering where this precision score, recall score, and F1 score comes from, as I've told you, we have imported. So we have imported F1 score here and imported recall score here and precision score here. So we are using those functions. So we know that for all these scores, true labels is the first parameter and prediction label is my second parameter. Okay, so which is similar to how we calculate this accuracy score. So here I'm going to print three statements. Okay, so if you want, you can return this precision value, recall value, and F1 score value. So for this function, so the purpose of this function is to print precision value, recall value, and F1 score value. So that is what we are interested in. So I'll put this text here as precision is equal to precision value. Let me just copy this and paste it quickly. And now we can replace this precision with recall, and here we can replace this with F1 score. Okay, so this recall value we have to paste here. So it is just the same thing that we have done before. So I'll show you in a moment. So we are just doing the same thing, finding the precision, recall, and difference score. So instead of doing this in three different steps, we are putting those together in a function, which will be helpful for you in several cases. So instead of doing that separately, you can set up this function and you can use that multiple times in multiple use cases that you are working on. So that's the idea of this, and nothing kind of new to it. So we are creating a function called as precision, recall, and F1 score, and these are the names of the parameters that we have to pass. So while calling this function, so instead of true label, we say y test prediction and prediction label x test prediction. For training data, we will say this true labels to be y train and prediction label to be x train prediction. So I'll run this function. And now, so we know that these are classification metrics, right? So I'll just put a text here as classification metrics for training data. So in the end of this video, I'll tell you where these scores are, very important. So classification metrics for training data. So let's name this as, you know, let us call this function, which is my precision, recall, and F1 score. So once you execute this, so these values will be printed. So these precision value, recall value, and F1 score value will be calculated, and we will print it. Okay. So let's pass the parameters, which are my, yeah, so this is my training data predictions, right? So I'll just copy these two things and paste it here. So the reason we are putting these two things is because we have true labels and prediction label as a uh, parameters, as we have mentioned here. So I'll run this one. So this will give me my precision value, recall value, and F1 score value, as you can see here. So which we have got previously. So this is the precision for training data 82.9, which we have got here. So similarly, we have got recall value and F1 score value for training data. Now we can just copy this. So instead of doing all those things, we just have to call this function. So this is for this data. So we are not doing all the things that we have done here. So we have calculated this recall and calculated this precision and so on, right? So you just have to call this function, replace this y train with y test, and replace this x test with x test prediction, and these three values will be printed. Yeah, so as I've told you, in this case we are getting the precision recall value to be the same for the test data. As these two values are same, we get the FN score value as also the same, as it is an harmonic mean. Okay, so this is how you can create a simple function that will give you this precision recall and F1 score. So you can also like kind of find these values individually if you want. So let's say that you are more focused on precision. In that case, you can just import this precision score alone. You don't have to go to recall and difference score and so on. So this is how you can create a function. Okay, so the main aspect in which we use this precision, recall, and F1 score is when your data set is imbalanced. So that is where these are like very helpful, because accuracy score will be misleading when your data set is imbalanced. Let's say that we are building a machine learning system or deep learning system that can look at an image and say whether it is a dog or cat. So let's say that we have 1,000 dog images and 100 cat images. So this is what we call as imbalanced data set, because the classes are imbalanced. So in that case, you will get a higher accuracy value, but it is not reliable. So I have explained about these things in the previous accuracy score value. So this is where precision, recall, and F1 score will be helpful for us. So in those cases, these values will be very less. So that is an indication for us to know that even the accuracy score is high, that the model is not performing well. Okay, so that is one main aspect. So you can just remember this or make a note of it. So precision, recall, and F1 score are very important in the case of imbalanced data set. And we also have a function in sklearn.metrics, which is precision underscore recall underscore F score underscore support. So this will give you four values: precision, recall, F1 score, and support. The support is another interesting aspect, which basically gives you, the number of true classes or the number of true prediction in each class. Okay, so so we are just in this case we have this art disease, people with art disease and people without art disease, and we are making predictions, right? So in each of these two classes, how many correct predictions are made? So that is the support metric that we have. But in the case of ML, we mainly focus on precision, recall, and F1 score. And it is always a good practice to calculate these three metrics along with the accuracy score as well. So people may work on some machine learning model trained with the data and calculate this accuracy score, but it is always a good practice in order to focus on this precision, recall, and F1 score as well. And this is a very important concept that you have to know, and this will be asked in several machine learning and data science interviews as well, as this is one of a key evaluation metrics that we have for binary classification problem. So that's it from my side. I hope you have understood all the things that is covered in this video. So please practice all these codes and see for yourself how these things works and so on. So that's it from my side, and I'll see you in the next upload. Thanks for watching.